What if I told you the greatest journey in human history is about to get a sequel? For nearly 50 years, two probes, relics of the 1970s, have been our only eyes and ears in the vast dark ocean between the stars. But their time is running out. Now scientists are designing a successor, a true interstellar explorer built for the 21st century, powered by next-generation systems and guided by artificial intelligence. This is the story of humanity's next great leap into the cosmos, so let's explore this together. The original Voyager achievement. Ever wonder what raw discovery looks like? Picture this, it's 1977, and NASA launches two spacecraft, Voyager 2 on August 20th and Voyager 1 on September 5th. Their mission, led by longtime project scientist Ed Stone, was to exploit a planetary alignment so rare, it only occurs once every 175 years. This grand tour would use gravity assists to slingshot from one gas giant to the next. What they sent back from their 23-watt transmitters about the power of a refrigerator light bulb redefined our universe. At Jupiter, they discovered the first active volcanoes beyond Earth on its moon Io and faint rings around the planet itself. At Saturn, they mapped thousands of intricate ringlets and flew by the haze-shrouded moon Titan. But Voyager 2 kept going, becoming the only spacecraft to ever visit the ice giants. At Uranus, it discovered 11 new moons and 2 new rings. At Neptune, it found 6 new moons and powerful 1,200-mile-per-hour winds. These weren't just flybys, they were foundational moments in planetary science, transforming our understanding of the outer solar system from distant points of light into complex, dynamic worlds. A journey into interstellar space. So what happens after you complete a grand tour of the outer planets? You keep going, farther and faster into the unknown. After their primary missions ended in 1989, the Voyagers began the Voyager Interstellar mission. Their new objective was to reach the edge of the heliosphere, the vast magnetic bubble inflated by our sun's solar wind that shields the planets from about 75% of galactic radiation. For years they traveled toward this boundary. Then on August 25, 2012, Voyager 1 made history at a distance of 121 astronomical units, or 121 times the distance from Earth to the Sun. It crossed the heliopause, the final frontier of our solar system, and entered interstellar space. Stamatios Tom Krimigis, a lead investigator, confirmed the data was undeniable. Voyager 2, on a different trajectory, followed suit on November 5, 2018, at about 119 AU. Now, Voyager 1 is over 163 AU away, the most distant human-made object in existence. For the first time, we were getting direct measurements of the interstellar medium, data sent from a place no probe was ever truly built to explore. Current limitations of the Voyagers. Here's the hard truth. The Voyagers are technological miracles, but they are also antiques from the dawn of the digital age. We're talking about spacecraft with a total of 69.63 kilobytes of computer memory, trying to send signals that take over 22 hours to reach Earth. Their data transmission rate is a painfully slow 160 bits per second, a speed that would make dial-up internet feel futuristic. Their instruments were state-of-the-art for the 1970s, but they were designed for planetary encounters, not the subtle environment of interstellar space. The biggest problem, as current project manager Suzanne Dodd often highlights, is power. The 3 radioisotope thermoelectric generators on each probe initially produced 470 watts of electrical power. Today that has decayed to under 250 watts and continues to drop by about 4 watts per year. To conserve every last drop of energy, the cameras were shut off in 1990 after taking the famous pale blue dot photo. Every year, more systems are powered down. Sometime around 2025 there simply won't be enough power to run any of the science instruments at all, and their historic journey will fall silent. The case for Voyager 3. With the original Voyagers fading, the question isn't just about continuing their legacy, it's about launching a revolution in interstellar science. The scientific community, including visionaries like Ralph McNutt Jr. from the Johns Hopkins Applied Physics Laboratory, isn't talking about a simple sequel. They're proposing a dedicated interstellar probe. This concept, often nicknamed Voyager 3, would be a machine designed from the ground up for a 50-year mission to explore the interstellar medium. It would carry a suite of modern instruments specifically built to analyze the space between stars with a precision the Voyagers could only dream of. The goal is ambitious: to travel 1,000 astronomical units from the Sun, which is more than 6 times farther than Voyager 1 has traveled in nearly 5 decades. This isn't about nostalgia for the Voyager name. It's about a critical scientific imperative. The Voyagers proved we could touch the stars, but they left us with more questions than answers. A new probe would be our tool to finally understand our place in the cosmic neighborhood. Advanced technology capabilities. So, how do you build a spacecraft for a 50-year journey to the stars? Well, you start with radical speed. A modern interstellar probe, as conceptualized by Ralph McNutt's team at APL, would need to travel much faster than the Voyagers. The plan involves a daring solar Oberth maneuver. The spacecraft would dive incredibly close to the Sun, within 4 solar radii of its surface, where it would be subjected to immense heat and radiation. At its closest point, it would fire its engine, using the Sun's immense gravity as a slingshot to accelerate to speeds approaching 95 kilometers per second. That's about 20 astronomical units per year, nearly 3 times faster than Voyager 1's current velocity of 17 kilometers per second. This would allow it to reach the heliopause in just 15 years. To survive this maneuver, it would require a revolutionary new heat shield made of carbon-carbon composite. Onboard, AI-powered systems would handle navigation and fault management, making autonomous decisions light hours away from home. Power would come from next-generation nuclear systems designed for a 50-year-plus operational life, ensuring it could send back a robust stream of high-resolution data for decades. The interstellar medium mystery. Why is it so critical to study the space between the stars? Because our solar system is not an island. It's a ship sailing through the interstellar medium, and the heliosphere is our hull. For years, we thought this protective bubble was shaped like a comet, with a long tail stretching behind it. But the data from the Voyagers, combined with models from astrophysicists like Merav Ofer of Boston University, suggests something far stranger. Her models indicate the heliosphere might be a deflated croissant or have 2 distinct jets, a shape no one predicted. The truth is, we don't know for sure because we only have 2 data points from the Voyagers. A dedicated interstellar probe with modern plasma and magnetic field sensors could finally map its true structure. It would directly measure the density of the local interstellar cloud our Sun is passing through, about 0.1 atoms per cubic centimeter, and chart the strength of the interstellar magnetic field. Understanding this interaction is fundamental to knowing our place in the galaxy and the nature of astrospheres around other stars. Scientific objectives and research goals. So, what specific questions would a new interstellar probe answer? Well, let's get into the hard science. The primary goal, as laid out in the Interstellar Probe Concept Study, is to understand the heliosphere as a habitable astrosphere. By directly sampling the pristine material of the local interstellar cloud, it could determine the true composition and state of the galactic medium our solar system formed in. Second, it would map the magnetic field structure from the Sun all the way out into the galaxy, revealing how our local magnetic bubble gives way to the vast magnetic field of the Milky Way. This is, critical for understanding how cosmic rays are filtered and accelerated. Third, from a vantage point hundreds of astronomical units away, it would be able to look back and image our entire solar system as a single system. It could observe the zodiacal dust cloud, the dust left over from the formation of our planets, and see how it glows, providing a vital ground truth for what telescopes like JWST are trying to observe around distant exoplanetary systems. It would, essentially, bridge the gap between our home and the billions of other star systems in the galaxy. Practical applications for future missions. This isn't just about pure science, it's about laying the foundation for humanity's future in space. A modern interstellar probe would be a crucial pathfinder, charting the hazards of deep space. Its most important practical application would be creating the first detailed map of the radiation environment beyond our heliosphere. We know from Voyager data that the flux of high-energy galactic cosmic rays is roughly 3 times higher outside our heliosphere. These particles can damage electronics and pose a significant threat to biological life. A new probe would measure this radiation with, unprecedented accuracy, providing the essential data engineers need to design shielding for future robotic and eventually human interstellar missions. Understanding the plasma turbulence and magnetic field orientation is also critical for developing safe navigation strategies. Just as early sailors needed charts of ocean currents and reefs, future interstellar explorers will need a map of the interstellar medium. This mission would create that first map, making the next steps in exploration possible. Cultural significance and golden record 2.0. Beyond the science, there's the story of us. The original Voyagers carry the golden records, 12-inch gold-plated copper discs conceived by a team led by Carl Sagan, Ann Druyan, and Frank Drake. They are time capsules carrying 116 images and 90 minutes of sounds and music from Earth, from Bach to Chuck Berry. They are a message in a bottle thrown into the cosmic ocean. A new interstellar probe would carry this tradition into the 21st century. Imagine a golden record 2.0, not an analog disc but a digital archive with terabytes of storage. It could contain the entirety of human knowledge, our science, our art, our music, our languages. It could carry a message crafted not just by a small committee but by humanity itself, perhaps even using AI to create a message designed to be universally decipherable. It would be a dynamic reflection of who we are now, a global, interconnected, and complex species. This probe would be both a scientific instrument and a cultural ambassador, carrying the story of a curious species from a small blue dot into the vastness of the galaxy for eons to come. Timing and opportunity. Here's why this conversation is happening right now. The original Voyager's Grand Tour was a once-in-a-lifetime opportunity. To achieve the immense speeds needed for a true interstellar mission in a reasonable time frame, we need a similar advantage. As identified by Ralph McNutt and the APL team, a powerful launch window opens in the 2030s. A launch in 2036 using a powerful rocket and a Jupiter gravity assist would provide the optimal trajectory to reach the target speed of 20 astronomical units per year. Missing this window would mean waiting until the next alignment in the late 2040s, a significant delay for a mission that is already decades in the making. The technology needed for the core mission is largely ready or in advanced development. This isn't a far-off dream, it's an achievable plan with a clear timeline. The Voyagers have been our scouts, but their journey is nearing its end. If we want to build on their legacy rather than letting it fade into silence, the time to commit is now. The cosmos is waiting, and the launch window is opening. From the revolutionary discoveries of the original Grand Tour, to the tantalizing mysteries of interstellar space, the Voyager legacy has pushed the boundaries of human knowledge. Now, with concepts like the interstellar probe, we have the chance not just to continue that journey, but to begin a new, bolder era of exploration. It would be a mission to understand our home in the galaxy, to test the limits of our technology, and to carry our story to the stars. The first Voyagers were our messengers to the cosmos. This next one could be our guide. Are we ready? Don't forget to like, subscribe, and hit the bell icon. Thanks for watching Future Facts.